So this video is going to be me going through some of our review questions that were found on our review that we went over in class. But it's just kind of going giving you another example to help you out if you need it. So feel free to use this if you'd like to. If not, that's okay too. I just want to make sure that you guys have all the resources possible to be successful on this test. I'm going to begin with number 1. And the first and most important thing is we read in the directions and it just says simplify. When we talk about simplifying, it's bringing our numbers, our radicals, our rational exponents, whatever we have, down to the lowest possible terms we can find. So in this case, because I have a fraction in my exponent, this is called a rational exponent. Remember, all fractions are rational. Okay, so in this case, since it's a power, it's a rational exponent. Any rational exponent can be rewritten as a radical. To be written as a radical, you have to take the denominator, which in this case is 2, and then the radical. Well, 2 radical or 2 roots are the same as just saying square root. You don't always have to write that 2, but we are now. Then I take the base, which is 16, and then I take it to the power of the numerator cubed. Now, 16 cubed, we're going to use this in our calculator. 16 to the third power is 4,096. So I'm taking the square root of 4,096. From here, you can go through and try to do all the trees if you'd like to break it all the way down, and I'd love you guys to do that. But at the same time, when I have this large number, it seems like it's going to break down for a very long time. So one thing I like you guys to always check on your calculators is see, is the square root of 4,096 a perfect square? And you can do that by pressing the second key, and then the x squared key, and you get the square root, get the radical up there. And then you're going to tell me your value, the radicand, the number inside the radical, 4,096. And it works out to be a whole number. So instead of having to go through the entire tree of figuring out that it's going to work out to be a perfect square, I use my calculator and it tells me it's just 64. And since there's no decimals or anything like this, I am left with 64 as my last answer. Now, number 2 is going to follow the same premise. I have to simplify. And again, I have a rational exponent. So when, again, I am presented with a rational exponent, I want to rewrite it as a radical. But what's different about number 2 is that in the rational, I have -1. Now that changes it, because instead of just going right into the radical like we did in number 1, the negative exponent forces me to rewrite it in the denominator. So instead of saying 27 to the 1/3 power, I have to do 1 divided by 27 to the 3rd power. Now the only thing that changes is just where I'm going to simplify my radical. Instead of just simplifying it up here, I have to actually just simplify it as it's in the denominator. So I follow the same protocol. I start with my denominator of the exponent, which is 3, which means it's a cube root, okay, 3 and then the radical. And then I put the base 27 to the power of the numerator, which in this case is just 1. The 27 to the first is just 27. So now I have my cube root. So what I would like to do now is break this down. 27 is not that big of a number, and we know that 9 times 3 are factors of 27, and then we could break down 9 to be 3 times 3, and then this 3 also has to come down. Now, because we're doing a cube root, I'm looking for groups of 3 of numbers that are all the same, and I have one here. It's just 3. There's nothing remaining, so I'm just left with 1 over 3. And this is as simple as it goes. There's nothing else I can change. So this is our first 2 problems on our review.